In this video, we're going to take a look at how you can use algebra tiles to model completing the square. And I've recorded this a couple of times. I'm trying to get a smooth set of models and examples to show you how it works. Now, if you're not familiar with algebra tiles, you can access them virtually. I'm on a website, just mathspot.com, looking at manipulatives and tiles. And this is essentially what they look like. But in a classroom, you might have like a little mini set of them that you can like spread out on your desks. Now, here's how they work. Algebra tiles take a algebraic polynomial, usually a quadratic, and model that quadratic using area. So it's pretty brilliant, actually. So you have a light blue tile here, and the area of that tile is x squared. So the width of the tile is x, and the height of the tile is x, and so x times x is x squared. The green ones have an area of x because they also have a height of x, but they have a width of 1. And so 1 times x would give you x for the area. And the yellow ones here have an area of 1 because their dimension is 1 by 1. And with that, you can model pretty much any polynomial. Now, you can also have negative x squareds, negative x's, and negative 1s. This is set so that it's not showing you all of those things, but they do exist. Now, here's the polynomial in question. We're going to start with difficulty level 0 here. And we have x squared plus 4x plus 4. And so what I'm going to do to model that is drag over the x squared. I'm going to drag over 4 x's. And I'm going to drag over 4 1s. And typically when you first start with algebra tiles, this is what you would start with doing, is just modeling the polynomial in standard form. So how many x squareds do I need? How many x's do I need? How many constants do I need? And so forth. Now, to complete the square, what you are literally going to do is rearrange these algebra tiles to make a square. And if we were doing this in a classroom, I might have my students experiment with it. So I might have them try to arrange it however they might want. So we'll put a third one here. Now, you do need to rotate. So there's a rotate button. And the rule of algebra tiles is that each side has to match up with a side of the same length. So you can't do that, okay? But you can do this, okay? And so we'll go and put that in there. And first of all, this is not a square, and also mostly it's just not a square. So to make this a square, you find out pretty quickly that however many x's you have, you're going to need to split those x's up evenly between the two sides of your blue square. So however many x's you go out this way is going to have to be the same number that you go out this way. Otherwise, you won't be able to fill in all the places to make a square. And you'll run into some issues. Now, if I go to plug these in, you will see that I have actually made a square. Okay, and I know that this is the equivalent of this because I'm using the same number of tiles. Like I haven't altered the tiles in any way. Now, what are the dimensions of this square? Well, this is x, and then remember each of these is 1. So this would be x plus 2 going across the width, and x plus 2 going down the length. So I know it's a square, and the dimensions would be x plus 2 times x plus 2, or x plus 2 squared. If I click show the solution, you can see it there. It's x plus 2 squared, and there's nothing for the plus b because I did not have anything left over. All right, so that is completing the square there. So we're going to tidy that up and look for a new example. Now, what I learned doing this is that there's only 8 tiles of each type. And so, yeah, I don't want to do one that has like a 10x because we'll run out of the, we might be able to do the 10x. No, we're going to run out of the ones if we do that. Let's try this one. So x squared plus 2x plus 6. Now, again, if we had more tiles, like those numbers are not an issue. It's just an issue of illustrating it with the tiles. So we have x squared plus 2x plus 6. Right, and so drag over those 6s. And again, the task here is to make a perfect square. So we're going to complete the square. And again, you could kind of play around with this, but you'll find if you do anything other than split up the x's, it's not going to work. So I'm going to rotate that. So that's the only way I can get the same dimensions. And then I can plug this 1 in, and that gives me a perfect square. And I got the rest of these guys just hanging out over here. Not super happy with that. But remember that we can also have like a plus b. So this would be x plus 1 times x plus 1, or x plus 1 squared, plus 5 that are extra. And there it is, x plus 1 all squared. There's the square with its dimensions, and there's what we have extra. Let's see if we can find one that has a negative. We might need to go up. Let's see. I know they exist because I have recorded this video multiple times. Maybe we need to go up to difficulty level 3. Yep, but we're not doing a negative 20 because we will run out of pieces. Negative 12 is kind of close. Oh, no, that had 14. 18. I think I've gone through all of those. Let's try difficulty level 4. Okay, so here's one. So x squared plus 4x minus 2. So we'll look at this. Now, I was looking for ones that had a negative like in the x's, so that we would use like the red rectangles, but no dice on clicking through. So maybe that I'll have to save that for another video. So we have x squared plus 4x, and this time we are going to have a minus 2. So your algebra tiles will accommodate negatives. Now, again, you want to make a perfect square. This is called completing the square. And as we have established, you would divide this number, however many rectangles you have, you got to divide that by 2, and then you put the rectangles on either side. And if you've done completing the square as an algebra lesson, what I just said might sound familiar. You take that b value, in this case, however many rectangles you have, and you divide it by 2. Now we have an issue. And there's 2 issues here. One is that I don't have enough of my little squares to complete the square. The other thing has to do with the sign. This is a positive 1 and a positive 1, and a positive times a positive cannot give me a negative, okay? Like they need to match up. So what I need to have there are positive 1s, and I don't have any. Here's the solution. Ask yourself, what is positive 1 plus a negative 1? Well, that would be 0. So I can add that and not change the value of this quadratic at all. So all I did was add a 0. And what that does is it gives me a 1 that I can put in there. And I can add as many, these are called 0 pairs. I can add as many of those as I would like. So I'm going to keep on adding those 0 pairs until I have enough of them that I can go ahead and complete the square. And so in this case, my expression would be x plus 2 times x plus 2. So x plus 2 all squared minus 6. So I got the minus 6 hanging out there, and there it is. So in a nutshell, that's how you use algebra tiles to complete the square. And you are certainly welcome to access this website, practice. If you've got algebra tiles, you can make them, you can buy them. Your teacher might have them to practice completing the square. Now, a couple things to note about completing the square. It really is only a great strategy in 2 situations. One, you want to have a 1 in front of your x squared. Is it possible to carry out the process if you have more than one of the big blue rectangles or squares? Yes, though you wouldn't want to do it with the tiles. You would do it algebraically. The other thing is you really, really, really like to have an even number as your middle coefficient there, because whatever that is, that's how many rectangles you have, and you want to be able to split them evenly. Can you do it with an odd number? Yes, but you end up with like fractions in your answer. So typically with completing the square, it's one of those strategies that we keep in our back pocket, but we don't pull it out a whole lot because it doesn't work real well if you've got more than one x squared or you have an odd number in front of the x. Now, if you have an even number for your x's and you have a 1 in front of the x squared, then it's pretty much going to work like this every single time, and it's not a bad strategy. It's also used in dealing with circles and in your derivation of the quadratic formula. So I hope you found this video helpful. If you did, please give it a thumbs up, share it, like it, drop me a comment, let me know what you think, and check out the channel for some other playlists and videos that you might find helpful.